Please start with our summary slide, answering the question, what did we learn in our previous lesson? So today our learning target says, I can factor a difference of squares. And our essential question says, how do you factor a difference of squares? So difference of squares was one of the special products that we worked with when we were learning how to use FOIL and the box method. So we're going to reverse that difference of squares. So instead of multiplying together the binomials a plus b and a minus b to get the difference of squares, now we're going to start with the difference of squares and figure out from the difference of squares what the two binomials are that would give us that product. So because factoring is like dividing, we're always looking for the factors that get multiplied together to give us that answer. All right, so difference of squares. Then we factored trinomials into two binomials. So we've already done that. We have factored trinomials, 3 terms, into 2 binomials. So now we're going to factor binomials that are the difference of squares. And we're going to use difference of squares to solve equations with the zero product property. Computer graphics designers use a combination of art and mathematics skills to design images and videos. They use equations to form shapes and lines on computers. Factoring can help determine the dimensions and shapes of the figures. All right, so the first one says find the product using FOIL or the box method. So we're just going to use FOIL. X times x is x squared. X times 4 is 4x. Negative 4 times x is negative 4x. And negative 4 times 4 is negative 16. So what happens when we multiply these together is these like terms here in the middle. Positive 4x and negative 4x are opposites. So they actually cancel out, leaving us with just x squared minus 16. So what we're working with today is the difference of squares like this, x squared minus 16, recognizing that they're both perfect squares, and writing the binomial factors that would multiply to give us that difference of squares. So if you look at the relationship, x times x is x squared, 4 times 4 is 16, and notice that one of our binomials has a minus and the other one has a plus. So that is why those middle terms canceled out. All right, so let's see what you think about these examples. So, first one, x squared minus 25. So the first perfect square is x squared. That's x times x. The second perfect square is 25, which is 5 times 5. And then remember, we need one to have a plus and the other one to have a minus. That's our answer. X plus 5 times x minus 5. Okay, next one. Same thing. First perfect square, second perfect square. See if you can write them. X squared, x times x, 9, 3 times 3, and then remember, one gets a plus, one gets a minus. That's it. Third one, maybe a little bit trickier. First perfect square is 16x squared. Second one is 81. So this one might require a little bit more thinking. What multiplies times itself to give us 16x squared? 4x times 4x. Remember, perfect squares, they have to be the same number. So I'm not talking about 16 times 1 or 2 times 8. They have to be the same. And then 81 is 9 times 9. And then remember, just put 1 plus and 1 minus, and that's it. So this factoring pattern is pretty quick to figure out. All right, same thing. So hopefully you've got the hang of it now. So the first one is 4y squared, and the second one is 36. 4y squared would be 2y times 2y. 36 is 6 times 6. So again, remember they have to look the same. So we're not looking for any factor pair of 36 or any factor pair of 4. It has to be a perfect square. They have to be the same. Next one, 1 and 9x squared. So 1 is 1 times 1. 9x squared is 3x times 3x. And then put in your plus and your minus. Last one, 25 and 49x squared. So 25 is 5 times 5. 49x squared is 7x times 7x. And then put in your plus and your minus, like that. So these binomials have to look the same, except for the sign in the middle. One is a plus and one is a minus. It does not matter which one gets the plus and which one gets the minus. Okay? Now we're going to solve the equation and then use the zero product property. So solving is just one extra step. So we factor first. So here's our perfect squares. So y times y, and 49 is 7 times 7. So if I put in my plus and my minus, and then remember this is an equation with the equal sign, you know you have to do the extra step anytime there's an equal sign. So if it's an equation, that's when you have to have everything on one side and you use the zero product property, okay? So that extra step is only when you see the equal sign. So now if you set these each equal to 0, what you'll notice is that it just flips the signs. We've worked with this before. So this first one is -7, and then the second one ends up being +7, like that. Second example. Our perfect squares are x squared and 121. So x times x and 11 times 11. Then put in your plus in one of them and your minus in the other. And this time I'm not going to write out my equations because I know it's just going to switch the signs. So +11 and -11 are still our answers. Last slide. Nope, another one. Okay, solve each equation, then factor again. Okay, perfect squares. So 16y squared means that they both have to start with 4y so that they look the same. And then 25 is 5 times 5. So 1 plus and 1 minus. And we have the equals 0. Now this one I would recommend that you at least set up and solve one of them, because this is not going to end up being a whole number. So if I subtract 5, I get 4y equals -5, and then divide by 4. So y equals -1.25. And then if I solve the other one, it is just going to be the same thing, only the opposite sign. So 4y equals +5, divided by 4. So this one is y equals +1.25. All right, I'm going to shrink this one a little. There we go. Okay, second one. Now we've got 9x squared and 4. So 9x squared means 3x is how they both have to start. 3x times 3x is 9x squared. And then 4 is 2 times 2. 1 minus 1 plus. And then if we solve 1, 3x equals 2. So then if I divide by 3, it's going to stay a fraction. So x equals 2/3. Or if you wanted to write that as a decimal, it would be 0.6 repeating. And then solving the other one is just going to give us negative 2/3 or negative 0.6 repeating. So make sure that you find both answers. Make sure you find both answers. Okay, last slide. Nope, those are just repeated to make sure. Yep, that was the last slide. Okay. So you know how to factor a difference of squares, and then you know how to use the zero product property to solve an equation involving the difference of squares.